In 1665, the smartest place in England shut its doors. Not because of war, because of death. A plague was spreading through London, and it was creeping toward Cambridge. The university had no choice. It sent everyone home. Among the students forced to leave was a quiet, unremarkable young man named Isaac Newton. He wasn't a star pupil, he wasn't popular. Nobody at Cambridge thought he was destined for greatness. He packed his things and went home to his mother's farm in Lincolnshire. He thought he'd be there for a few weeks. He ended up staying almost 2 years. No professors, no classmates, no university library. Just silence, fields, and time. An enormous, uninterrupted amount of time. Most people would have called this a disaster. A career interrupted, years wasted. Newton did not see it that way. He saw it as the first real chance he'd ever had to think, without anyone telling him what to think about. He started with light. He bought a glass prism and let a single beam of sunlight pass through it. The light split apart into colors: red, orange, yellow, green, blue, violet. Everyone assumed colors came from the glass itself. Newton proved they didn't. The colors were already hidden inside ordinary white light. The prism only revealed them. Then he turned to something bigger. The story usually told is simple. Newton sat in his garden. An apple fell from a tree. And suddenly, gravity was discovered, like a light switching on. That's not quite what happened. What actually happened was quieter and arguably more impressive. Newton watched an apple fall. He noticed something specific. It fell straight down, not sideways, not at an angle. Straight toward the center of the earth. And he asked a question almost nobody else had thought to ask. If the earth pulls an apple down, does it pull on the moon too? The moon never crashes into the earth, but it never flies off into space either. It just circles forever, like it's being held on an invisible leash. Newton wondered if it was the exact same force, just acting at a much greater distance. This single question would take him years to fully answer. He didn't solve it instantly under that tree. He carried it with him on and off for nearly 2 decades. But the seed was planted right there, in a quiet garden, during a plague no one invited. While he was at it, he didn't just rest on one breakthrough. In that same stretch of isolation, Newton also developed an entirely new branch of mathematics, a way of calculating motion and change moment by moment. Today we call it calculus. He needed it to even attempt describing how gravity worked. Eventually the plague faded. Cambridge reopened. Newton returned. He came back the same age he'd left. But not the same mind. He brought with him the early seeds of optics, calculus, and a theory of gravity that would eventually rewrite how humanity understood the universe. It would take another 20 years before he published it all properly. In 1687, he released a book called the Principia. Inside it were his 3 laws of motion and his law of universal gravitation, the same force that pulls an apple to the ground, the same force that keeps the moon in orbit, the same force that holds entire planets on their paths around the sun. One simple idea, one unifying force, applying equally to a falling fruit and an entire solar system. It is still considered one of the greatest single contributions in the history of science. Near the end of his life, Newton looked back on everything he'd achieved. And he didn't describe himself as a genius who saw further than everyone else. He compared himself to a boy playing on a beach, occasionally finding a smoother stone or a prettier shell, while the true ocean of knowledge remained almost entirely undiscovered in front of him. A plague shut down his university and sent him home with nothing to do. He used that nothing to rebuild how we understand light, motion, and the universe itself. Sometimes the world doesn't stop your work, it just clears the room you needed all along.